I'm Dr. Matt Brown. I'm a research scientist at the University of Alberta in the Department of Psychiatry, and I study brains. We use brain imaging to look at brain activation patterns. Georgina approached my colleague, Dr. Andy Greenshaw, about the healing journey, and she wanted to know if we could take some measurements of brain activation patterns related to the healing process. What we went with was a emotional picture viewing task. So in this, we had Georgina lie down in the MRI scanner and she viewed pictures. Some of them were neutral, and then some of them showed aversive or positive emotional scenes. And we recorded her brain activation patterns. We did this at the beginning of the healing journey and at the end, and compared the activation patterns to look for changes related to the healing process. So the technique we use is called functional magnetic resonance imaging. The brain imaging method that we use is very powerful, but it also has limitations. One of the limitations is that the meaningful signal is actually quite subtle. It's quite faint. It's somewhat like trying to listen to someone talk very quietly in the middle of a party. So typically what we do is we try to take lots of measurements and then we use averaging to try to boost the signal that we can detect. And in a typical science study, we would have many participants. In this case, we have a single participant who is Georgina. So this is a pilot study, but we were still able to observe some differences, which was very interesting. So we were able to observe some set of differences that we were looking for, another set of things that we would have liked to see, namely differences between emotional pictures and neutral pictures. We didn't actually see that in this case, and I think that's simply a result of having only one participant, as opposed to what would be more typical in a science study like this would be to have, for example, 20 participants, just so that we can better resolve the signal. But we were still able to look at some interesting differences between the overall activation patterns that we found in Georgina's brain from the first and second scans. In other words, from the first and the kind of pre and post or before and after scans. And just to give a brief summary of those things, so we were able to find activation differences related to performing this task, so related to viewing these pictures. And as we expected, this sort of task causes activation changes all over the brain. We used brain imaging to look at activation patterns in Georgina's brain, and we were particularly interested in regions that are related to emotion processing and regions that seem to be involved in things like self-awareness and self-assessment. In some of these regions, in the first scan, the scan at the beginning of the healing journey, these regions were showing what we call deactivation. So their activity levels, they decreased. They were sort of negative activity levels while Georgina was viewing the pictures. In comparison, during the second scan at the end of the healing journey, those same regions were showing activations. So instead of a deactivation, they're showing an activation. And it's possible that this is related to a healthier brain state, that these regions, instead of being sort of deactivated or turned off, are now turned on, or they are now active. Mental disorders are I think they're an unrecognized problem in many cases. I mean, some people obviously do recognize these things, and many individuals or their family members are affected by mental disorders. In terms of sort of health funding and research funding, mental disorders are underrepresented. And if you simply look at numbers, if you kind of take the impersonal economic view, the damage that's done by mental disorders is quite a bit larger in comparison to the funding that's used, or sort of the funding that's applied in terms of health services or in terms of research. So things like looking for approaches that are effective and sort of that are effective at an individual level and that are cost effective, this is really important. I mean, there's huge benefits to individuals that you can accrue from this and to society as well. So I think this is an excellent project in terms of trying to go that route. Okay, so here we see some results from the brain imaging scans. In this one, we're looking at a view of Georgina's brain. So that's the bottom, the back, front, left, right, and we're looking from the top down. These colorful parts are showing activation differences. So this is a statistical comparison between the second and first scans. The colorful regions show brain regions that had different activation levels after the healing journey compared to at the beginning. This particular region, which is outlined in a purple square, that's called the anterior insula on the right side. This purple square region, highlighted here, is called the anterior insula on the right side. This region is involved in emotion processing, things like making value judgments. So obviously very important for going about day-to-day life. If you look at this region and you look at the activation patterns, you can see them in this graph. The red dotted line is the activation profile from the before scan. The red activation profile shows the activity level before the healing journey. The blue line shows the activation profile in the right anterior insula after the healing journey. Here we see the activation profiles in right anterior insula for the after compared to before healing journey. You see that before the healing journey, this brain region, which is involved in emotion processing, was deactivated. So it was shutting down when Georgina viewed the emotional pictures. In comparison, after the healing journey, this right anterior insula region showed activation. So it's coming online when Georgina viewed the emotional pictures.